Previous segment, we proved that bad prime is a subgroup of Z star n, but I wanted to show to you that it is a strict subgroup, meaning there exists some element in Z star n, say element B, which is not present in bad prime. Okay, that's something we need to prove. All right. So recall the Chinese remainder theorem. If you know a number n that can be written as product of two numbers n1 and n2, which is possible if n is a composite number, right? And we assumed n is not a prime power also. Therefore, the GCD of n1 and n2 must be 1. Okay. And now Chinese remainder theorem is telling us that any element that you take in Z star n is basically mapped to a pair of elements, one in Z star n1, another in Z star n2. That's because of Chinese remainder theorem we talked about earlier. Okay. So what it means is that if we take an element A in Z star n, we can map it to an element A1 in Z star n1, A2 in Z star n2. Okay. Now I leave this as a homework for you to show that -1 maps to -1, -1. This is easy to prove. Okay. And now let's consider the higher level picture. We wanted to be able to show that an element B, which belongs to Z star n, is not a member of bad prime. Okay. How do we go about proving it? First, we take an element A from bad prime as follows. We wanted to select an A such that A power, okay, 2 power I times U is equal to 1. Okay. Will that be possible? Or equal to -1 rather. Okay. Will that be possible? Yes, it is possible because we proved that -1 is part of bad. And we also proved that bad is a subset of bad prime. That means we should be able to find an element in bad prime such that A power 2 power I times U is equal to -1. Okay. But what is this theorem saying here? Chinese remainder theorem is telling us -1 will be mapped to -1, -1 in n1 and n2. Okay. Which means that our A, let's take A. Okay. A corresponds to A1, A2, right? Which means A1, comma A2 power of 2 power I times U is also -1 because -1 maps to. Okay, now we can conclude that A1 power 2 power I times U is equal to -1. A2 power 2 power I times U is equal to -1. Okay, that's because -1 maps to -1, -1. Okay. Okay, what does it tell us? And now comes the interesting conclusion. We take. Okay, well, let me first finish this. Okay, this is clear. This implies that A1 power 2 power I times U is equal to -1 in mod n1. Okay, that's important. This is the first factor, n1. And A2 power 2 power I times U is equal to -1 in n2. Okay, that's because of Chinese remainder theorem. And now we can consider an element B in Z star n and show that B doesn't belong to bad prime. How do we do that? We take a B such that B maps to A1, 1. Okay, this is possible, right? Chinese remainder theorem allowed us to map any element in Z star n to a corresponding pair of elements in Z star n1, Z star n2. Since Z star n1 and Z star n2 are groups, the number 1 must be part of the Z star n2 in this case. Okay, a Chinese remainder theorem allows us to map a pair from Z star n1, Z star n2 back to Z star n. That's what I'm doing here. Okay, and now consider B power 2 power I U. Okay, what is B power 2 power I times U? Well, this is nothing but, again, applying Chinese remainder theorem, A1 power 2 power I times U, 1. Okay, but what is this? The first element here. What is the value of this element in n1? In n1, this is nothing but -1. Okay, this is nothing but -1, 1. Okay, so what is -1, 1? When you map it back to Z star n, it cannot be +1. It cannot be -1 because in order to be +1, you need to have 1 and 1 here. In order to have -1, you need -1 in both places. Therefore, this element cannot be mapped to + or -1. Okay, so what did we achieve then? We successfully proved the fact that we took an element in B and shown that element is not in bad prime, because in order for it to be in bad prime, that element must satisfy this property + or -1. A power 2 power I U is equal to + or -1. In this case, B power 2 power I times u is equal to plus or minus 1. But we found an element b which is not equal to plus or minus 1. B power 2 power I times u is not equal to plus or minus 1. Okay, that means we convinced ourselves that bad prime is a strict subgroup of z star n. All right. Okay, that's all. Thank you very much.